The pressure input to a hydraulic system is the same as the pressure it will output. Remember that hydraulic systems work by transferring pressures through incompressible liquids, which helps transfer and amplify forces. When doing a calculation involving a hydraulic system, we should remember that the pressure input is equal to the pressure output, since the pressure must be the same throughout the entire liquid used. For example, let's consider a simple hydraulic lift, where we push down on a pedal on one end to raise a large platform on the other. So here, the input force is what we push down on the pedal and liquid with the input area being the area of this pedal in contact with the liquid. Then the output force is what the liquid will push against the platform with the output area being the area of the liquid here. Though in an exam question, it will usually be made clear what areas to use in a calculation. Then, because of how hydraulic systems work, the input pressure must equal the output pressure. Also remember that pressure is equal to force divided by area. So the input force divided by the input area must equal the output force divided by the output area. Many students struggle with hydraulics calculations because they don't know where to start with them. The key is to find the input and output forces and areas, and remember this relation between the pressures. So let's try an example calculation. A hydraulic lift is used to raise a light 10 meter squared platform with a 10 kilonewton car on it, as shown in the diagram below. Calculate the minimum force that would need to be applied to the lift's 0.2 meters squared pedal in order to raise the platform with the car on it. So lifting up heavy objects like this is a very common application of hydraulics. So step 1 is to list the key information on the diagram and check the units, where we should use the diagram to make sure we understand what's happening in this problem. So we're told to find the force applied to the pedal, which has an area of 0.2 meters squared. These will be our input values. Then for the output, we have an area of 10 meters squared, and it has a car with a weight of 10 kilonewtons. In order to raise the platform, we need the liquid to have an upward force greater than this downward force. So the minimum upward force we'd need would also be 10 kilonewtons, though we should convert this to 10,000 newtons for our calculation. Then in step 2, calculate the pressure the car's weight exerts on its platform, where we calculate pressure using the equation pressure is equal to the force normal to a surface divided by the area of the surface. The weight of the car is 10,000 newtons, and the area of the platform is 10 meters squared. So the pressure the car exerts on the platform is 10,000 newtons divided by 10 meters squared, which equals 1,000 pascals. Remember that pascals are units for pressure and are the same as newtons per meter squared. In step 3, deduce the pressure needed to be exerted on the pedal in order to overcome the car's weight. Remember that the key to solving hydraulics questions is that the liquid used will have the same pressure throughout. So whatever input pressure we give to the pedal will become the output pressure at the platform. So since we need the output pressure to overcome the 1,000 pascal pressure from the car, we need at least 1,000 pascals in the input. Now we know what input pressure we need, we can calculate the force that will create this pressure. So step 4 is to rearrange the pressure equation to make force the subject. So to get force on its own, we can multiply both sides by area to bring the force over to the left. This gives us that the pressure times area will equal the force we need to find. And finally, step 5, substitute in the values to calculate the force. So we'll need our rearranged equation. Force normal to a surface is equal to the pressure multiplied by the area of the surface, where we've just flipped this round from the previous step. So we're told the pedal is 0.2 meters squared in area, and we know the pressure we need in the hydraulic system is 1,000 pascals. So the force we have to apply is 1,000 pascals multiplied by 0.2 meters squared, which is 200 newtons. Notice that because of how the system works, we only need a small force to raise the heavy car.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!